vector equations. So what are vectors? Rn, remember Rn means n copies of R, or the real number line. So R was real number line, and R2 was, if you recall, I told you this is the plane, and if R3, that is the space, and then after that we cannot imagine, or we don't have like names, but these are just the regions, you can say. So in Rn, an n by 1 matrix is called a column vector because it will have only one column and but n number of rows. So for example, something like this. And I explained that vector is usually denoted by bold letters, or we can put an arrow or a bar on top of it. So like this is a vector, this is a vector, this is a 3 by 1 vector, this is a 2 by 1, and this one is the last one is the n by 1 vector. So we say two vectors are equal if only their corresponding entries are equal. And also the first thing actually should be that their size is equal. They have equal size, and then also not that only they are equal size, but also their entries are same. For example, we can have a 2, 3 here, right, equal to, if I say is this equal, are they equal, like x plus 5, well, okay, let's say this 5 minus 3 and 7 minus 4. Are they two equal? Yes, because this also yields 2, 3, and so they are equal vectors. So it means whenever you have this situation that x, y equals some number 5, 7, when you see something like this, it means you can say x is equal to 5, y is equal to 7. Given two vectors u, v and a scalar, so if we have two vectors u and v, and then you can add them. How do we add them? We just add the corresponding entries, corresponding elements. And cu means multiplying a vector by a scalar. So how do we multiply it? We multiply each and every entry of the vector with the scalar. So geometrically, vectors in R2 or R3, this is called plane and space, remember, are represented by arrows starting at the origin and ending at the point whose coordinates are given by the entries of the vector. So I showed you in space, in the plane, you can always draw a vector like this. So it starts at origin. So let's say this is the u vector. So for example, in the up there we have a vector 2 minus 1. So how will you draw this one, this vector? This is the coordinate axis, this is the origin. So you will start at the origin and go to the point 2, negative 1. So 2, negative 1 will be 2. Let's say this is negative 1, so it will be over here. So your vector is this. Now in space also we can imagine, it's hard to draw them on a paper, but that is how it works. So parallelogram rule for addition of vectors in R2. So we say if u and v are represented by as the points in the plane, then u plus v correspond to the fourth vector of the parallelogram whose vertices are 0, u and v. So what does that mean? It means, so the parallelogram law works like this. So you have two vectors, let's say a, or u, and let's say this is v. So one vertex is this is the other vector, and then we make a parallelogram like this. So the resultant is this one. This is called the parallelogram law. So you note what we did. We just joined this u vector was already there, so we picked the v vector from its position. We moved it to the right and a little bit up, and we put it on top of the u vector. So we join the tail of V with the head of U, and that makes it U plus V. You can think of it like this. This is the resultant, or you can think of it in terms of the parallelogram. So this is how we add vectors geometrically. Now physically or mathematically, we just add by adding the components or the corresponding entries of the vector. Now the zero vector is very important. So the zero vector is denoted by just 0 and then arrow on the top, and it has all entries equal to 0. So all the entries in the zero vector are 0. So, but which size? Well, it depends. We usually don't put the size with the name zero vector, but it should be obvious from the context which type of vectors are we using. Accordingly, that the zero vector will be of the same size. We now look at some algebraic properties of the Rn. So it says that adding two vectors, it doesn't matter that you add u in v or v in u, and this is called the commutative property. And similarly, if you have three vectors, it doesn't matter whether you add u and v first and then add w with it, or you first add v and w first and then u. The third one is saying u plus 0 is equal to 0 plus u. So u plus 0 is equal to 0 plus u, because like 2 plus 3 is equal, 2 plus 0 is equal to 0 plus 2, right? And then u plus negative u is the same as negative u plus u, which is equal to 0. C times u plus v is equal to c times v plus c times u. C plus du is equal to cu plus du. You can see these are called the distributive properties. These two are distributive properties. And this is the scalar multiplication. This is also, this is called the identity property or multiplication by 1. And then additive identity property, additive inverse property, and so on. Anyhow, you don't need to remember the name, but you should know how the property works or how this rules work. Linear combination. So what is a linear combination? Given vectors v1, v2 up to vk in Rn. So all of these are of size n by 1. And given scalars c1, c2 up to ck. So the same number of scalars as the number of vectors here. Then if we can write a vector vy as this c1 v1 plus c2 v2 plus c3 v3 plus so on up till last one plus ck vk, then this is called the linear combination of v1 up to vk with weights c1, c2 and up to ck. The weights in a linear combination can be any real numbers including 0. For example, so this is a linear combination of v1 and v2. This is also a linear combination of v1, v2. This is a linear combination of v1, v2. So let us look at example. This says determine whether B can be written as a linear combination of a1, a2 and a3. So what we do is, basically this means solving a set of equations. So this, in order to determine whether B can be written as a linear combination of a1 to a3, it means you have to solve a set of simultaneous equations given by this equation, and this is called the vector equation. So down here you see this. Solving an example like this involves solving a vector equation. This one, that's what I wrote up there. where x1, x2, x3 are to be determined. So we can name them x1, x2 or c1, c2. They are all to be determined. So we have to solve the equation. So this equation, and note that this vector equation has the same solution set as the linear system whose augmented matrix is this. So if you recall, this is what we learned, that if we have this set of equations, we can always produce or write the augmented matrix and operate or apply the operations, row operations on the augmented matrix and get the solution if the solution exists. So we say that B can be generated by a linear combination of these vectors if and only if there exists a solution to the above linear system. If there is no solution, then we say B cannot be written as a linear combination of the vectors. Okay, I will solve this example later, and I think I will stop here and do the rest in the next video, so that the video doesn't get too long.